What is up, YouTube? In this video, we are going to cover what are the skill sets that are required to become a data engineer. If you're interested in breaking into data engineering, this video is definitely for you. For this video, I kind of prepared an exhaustive list of technologies which are out there in the field of data engineering. Also, I wanted to mention that sorry it took me some time to push out this video. I was kind of out sick and wasn't feeling really well. Alright, so as I mentioned, I prepared this mind map which kind of covers extensively what kind of skills you need to become a data engineer. Let's start with the basics first, which is fundamentals. So within fundamentals, you can clearly see there are a few things which are really core for you to become a data engineer. The top one in this list is actually SQL, structured query language. Almost all the databases and warehouses uses a version of SQL as a language to interact basically. One other thing I also want to mention, like SQL, even though it started with the relation databases, but now other technologies such as warehouses, lakehouses have kind of adopted it as an abstraction. One of the reason is being that SQL is kind of really well adopted within its users. So SQL's adoption within data practitioners is quite high. Almost anyone dealing with data, software engineering kind of know their way around SQL. So I think that's one of the key reasons. So the next up in fundamentals is kind of programming language. This is the language where you use to code most of the stuff. Basically, this is like the central language you will use and code things. So there are a few choices. Actually, there are a bit more choices than what I mentioned. There's Python, Scala, Go, and Java. So basically, Python is kind of the language of choice, easy to really get started with if you're like really new to engineering, software engineering. One of the other key aspect of Python being really popular is it is really packed with the data science packages and frameworks. So basically, it is really packed with data science packages and frameworks. You can also deploy production code with Python. Moving on, next up is, which is like a really important skill in general for software engineering, which is Git. So Git is a technology for you to enable version control in your project. So version control is kind of a practice of tracking and managing changes for the software you kind of code. So it helps you manage all your code that you write on. For every change you make and you commit, as a part of the change, you commit this code base in some kind of a remote server or cloud. It is kind of really important if you're working with a team and you don't want to lose code and actually collaborate and work together. Moving on, as part of data engineering, a lot of the time you would be dealing with Linux virtual machines or servers. Basically, you would be using some version of Linux, like maybe Ubuntu or Fedora, etc. So therefore, dealing with them, you kind of requires you to have some knowledge on commands on how to navigate within Linux servers. Like, for example, cd and pwd are like one of the first commands you would write down. ls is like showing things within directories. So I think it's like very important to know like Linux commands is very important. Apart from that, like these Linux command can be written down as a programming language. So if you want to automate stuff and not just write down commands manually, you can use shell scripting to kind of automate it further. Moving on, last one on the fundamental list I've kept is data structures and algo. First of all, you need to realize that even though you don't create data structures on your own, you use some kind of packages or some kind of inbuilt data structures from languages such as Python already has it. But it still makes sense to have a good idea and understanding of what data structures and algorithms are. At the end of the day, data engineering comes under engineering. So if you want to break into data engineering, you need to have some kind of problem solving skills using data structures and algo. I think that's how the general interview process of engineering kind of works. Easy lead code problems is a really good start for you to be, and then you can go on to medium. I would not recommend doing hard problems yet. Even I don't do it myself a lot. So I think it's okay for you to just skip that for now. All right, so let's move on to the next, which is networking concepts. So since you're dealing with a lot of like these VM servers, APIs, Python code, it is good to have a really basic understanding of basic networking concepts such as SSH, TCP, HTTP, HTTPS protocol, firewalls, virtual private cloud or VPCs, DNSs, IPs. SSH is like one of the commands you would use a lot. So one of the things is that I've added links in all of the concepts. Usually you use SSH protocol to like from your local server to go on to like the remote host and like securely access it. Similarly, I've added like details on what these networking concepts are in detail. Feel free to check it out. All right, so next up is databases. This is where all the structured and unstructured data kind of resides for you to use, the logical data coming from different applications. There's a long list of databases you would work with as a data engineer. Let's look into like the really base concepts of like traditional relational databases and how it works. You need to know like very simple concepts such as what is the table. Within a database is a table which consists of rows and columns, and then there are primary keys which is like unique and not null to each row, and then there are foreign keys which connect different kind of tables. You use joins and foreign keys together. Like with foreign keys you join multiple tables together to merge them and see. There are joins, merges, and then there's schema. Schema is like the structure of the table, so everything's in relation databases, everything's kind of fixed. So yep, these are kind of the details you would need to know. There's a bit more. I've left a link here, you can always click on it and see. Moving on, you can see SQL is again here. You need to use SQL to interact with these databases, relation database definitely. Moving on, next up is like ACID properties, atomicity, consistency, isolation, and durability. These are like the basic properties every relation database should kind of have. Moving on is database modeling. I think this is also like a really important concept. Before you build any database or application or warehouse, you would need to have some kind of knowledge on the design patterns of building schemas for the databases. There's a multiple type of schema design you can have. I've added a link for you to check out. Like star schema, denormalized schema. There's a lot more different types of schema you can develop, like the design patterns on developing these like models, developing these like schemas, which is essentially called database modeling. So yeah, moving on, there's a few more things like database scaling, how database scaling works. There are two options. One is vertical. Vertical is basically increasing configuration of the single machine, where the database is actually deployed in a single machine, which can be scaled up later on. Other is horizontal. Instead of doing it on single machine, you do in multiple machine, which is essentially called sharding. So you store parts of data in part of the machine and another machine, something like that. So you shard that data and put it into multiple places. Another concept you need to be familiar with, OLTP versus OLAP. I'm going to cover it in detail later down the road, but I just added again in the fundamentals. So OLTPs are online transaction processing databases, which are the regular databases, and OLAPs are like basically data warehouse analytical processing databases. So yeah, there's a key difference in it. I will cover in detail next. All right, next up is traditional style databases, which is relational databases. I'm covering here. Most of the applications are kind of being powered by these relational databases. There's a lot more options. I've just added two here. I've added a link. Feel free to check it out. PostgreSQL and MySQL are the most common ones you would interact with. They both essentially use SQL for you to work on. My understanding is Postgres has a bit more commands outside of SQL, which can be used like inserting data at scale, something like that. So yeah, definitely check them out. It's good to know that these databases exist. At least have some experiences with one of the data relation databases. So then you would know how to navigate with the tables, how to navigate with the data schema, etc. So I think it's kind of required knowledge to have for a data engineer. All right, moving on, we're going to non-relational databases. For this section, I would recommend, it's okay if you haven't worked with any of the technologies. It's good to know that these kind of databases exist. Even if you haven't worked with it, I think it would be fine. You would be easily be able to work with them later on. Good to know that they exist, what kind of different types of database exist in the non-relation space. And that's what I've categorized is like, one is like key value, one is Redis, which is like one of the most popular one. DynamoDB is from AWS, Firestore is from Google, RocksDB is from Facebook. So yeah, these are the different types. So key value pair is basically, you can consider it as a dictionary. There's a key and then there's a value. As simple as that. You basically are storing records as key value pairs in detail. So yeah, this is one type. Another is graph databases. I don't know if you got some chance to look at it. Basically, these are like special type of databases to kind of hold in relations. The data is kind of stored as nodes and relations separately instead of storing data as tables. So it's more around like creating graph with the data. The idea is for solving graph problems, you kind of need a data to be stored in a certain way to kind of extract it and fetch the records quickly. So that's where this kind of space kind of exists. So yep, one of the most popular ones is like Neo4j, which is out there. It has its interface of its own. It's query language as well, which is very similar to SQL. So I think it's okay if you encounter it. But yeah, it's good to know that these kind of exist. There's another one called ArangoDB that I've worked with, another kind of graph database, open source, which is free to use. So yeah, check them out if you're interested in. Moving on is like white column databases. So these kind of databases are really important for high throughput applications. They are really important for like fintech space, I would say, trading, etc., where there's like you need like really low latency in terms of like how the stocks are moving up and down. I think this is where these tables are really important. Two of the options I've added here is like Google Bigtable, which is from Google Cloud, and then there's Apache Cassandra, which is also like an open source big data technology for you to use. So yeah, these kind of exist. Good to know. All right, next up is data warehousing. So when databases are not big enough to store your data and it's not easily navigable, like as in terms of queries, data warehousing kind of comes into the picture. These databases are designed with the analytical workloads in mind. They are powerful for doing complex aggregated queries. So one of the things I've mentioned is SQL. Why SQL is relevant in the warehousing? The reason being, even though these warehouses are complex and has a lot more moving parts, but they have abstracted it away from the users by adding just SQL. So users just need to have some knowledge on SQL to kind of use them later on. And they've kept SQL at the forefront because it is very popular among data professionals. So yeah, some of the other concepts it's good to look at is like what is normalization, what is denormalization. It's basically different ways of storing data into databases or warehouses. So yeah, definitely check it out. There's a detail of what is online analytical processing databases versus online transaction processing databases. Definitely check this one out, as I mentioned before. So yeah, this gives you a great insight why there's a warehouse space exists, even though there are databases, but why there's data warehousing still exists. So yeah, let's look at some of the technologies that you might use in terms of using data warehouses. First, one of it is like BigQuery, which is Google's BigQuery, Amazon's Redshift, Synapse from Azure, Snowflake, which is an independent company, ClickHouse, I think, which is like an open source database for you to use. There's Hive, which is as part of Hadoop technology. Again, it is okay to not have hands-on experience with these kind of technologies. At least one is good enough, but even if you don't, you can always feel free to check it out in detail, but at least have knowledge on like what they are, why they exist in this space. So at least if you know these technologies, it's good enough. Next up is object storage slash data lakes. That's what I've added. So you can consider them to be like file storages, like just file storage you can put in your files, file or blob storages that are kind of globally available. At least in the case of public clouds, they are globally available for you to use. These are more like private clouds, like HDFS is that. So yeah, a lot of the times these object storages are used to create data lakes. That's why I mentioned data lakes in hand. So these are basically unstructured storages. You can put in files, images, or even like CSVs or data like Parquets. These are very cheap to work with. So like they're relatively cheap, readily available, and you can store massive amounts of like petabyte scales of data. So hence these technologies are relatively really being used to construct data lakes. In terms of the scope of data engineer, it is good to know how to interact with them. There's a lot of the time there's like console, you can go to drag and drop files, but also there's like also there are like command line packages like gcloud or AWS S3 CLI. So you can use them to basically use like Linux command to basically interact with them very easily. Moving on, distributed systems. So when multiple machines work together as a cluster, they kind of come into this space of distributed systems. So basically why this distributed system kind of exists, like the concept exists, because when the data is kind of really large enough, the idea is it cannot be managed by a single machine. This is when the distributed system come into the picture. Distributed system kind of introduce their own complexities. Therefore, having like their own tech, like which is cluster tech and open source tech for you to use, is separate. So you can not just use random Python to interact with this system. It won't be like really efficient to work with. Hence, they have their own tech to work with. So there are a few concepts around distributed system. Hadoop is like a set of framework that allows you to have distributed processing across a cluster. So I think this is like the base, and the storage is like corresponds with Hadoop, that when there's big data you can not store in a single machine. So Hadoop distributed file system is like storing files into distributed system. So like different clusters, machines, so it separates the data. Moving on to cluster tech, cluster technology, there are a few options to work with. So creating clusters on your own, you can use these services which are readily available as a part of public cloud, which is GCP Dataproc, Amazon EMR. There's something from Azure I haven't added. Let's just figure it out later. There's Databricks. You can create Databricks cluster. You can also create Kubernetes cluster to work with. So this is the cluster tech space. I think it's important to know at least one. I think Amazon EMR is like a very good example. But if you haven't worked with it, I think it's okay for now. But if you are interested in the scope of like big data processing, definitely you will need to know these kind of concepts. Moving on is like the open source tech you kind of work with in distributed systems, like how you process this data across this tech. So there's like Pig, Kafka, Spark, Zookeeper, Hive, Thais, Cassandra. I'm going to leave a link as well, but these are the technologies that you kind of use it. Even if you haven't worked with it in detail, I think it's okay. Spark is kind of one of the main important technologies nowadays to do processing on big data systems, distributed systems at least. There's Hive, there's Thais, there's also Pig, which is a SQL-like interface for you to use. So yeah, keep them in mind. Definitely check it out if you have the time. I think it's good to know some detail on what these technologies are. Even though you haven't used it, at least keep in mind like what these technologies are, why they are existing in this space. Yeah. Next up is data processing. While doing this, you clean the data, remove ambiguities, validate the data. So all these steps are kind of figured out with code in this data processing step. So one of the first technologies you can use with Python is pandas. So that comes under data processing, not big data processing, but if it's like smaller scale data, CSVs, or like Excels, or like data which is not relatively like huge, definitely you can use that can fit in memory. You can definitely use pandas to do all these different transformations. Data scientists actually use a lot of pandas on a daily workflow. But yeah, it can be used for processing and transforming data, definitely. Next up again is SQL, which is here. The reason being, a lot of these big data warehouses support SQL, and then they can do transformation at scale. Next up is the big data batch processing. So as I mentioned previously, big data is the data you cannot use in one go in a single machine. So yeah, you need clusters of machines to achieve it. So hence they have their own separate technologies such as Pig, Spark, Apache Beam. So these are different tech which can you use to like transform data at scale. So yeah. Similarly, stream processing also consists of Spark and Apache because these technologies support the same. So one of the key things in stream data processing is like the processing is being done in real time. One of the key concepts behind like real-time data processing, like stream data processing, is windowing. So instead of analyzing as a whole, you analyze in chunks of windows. There's a few options within windowing, like moving windows, fixed windows, etc. But then you use windowing to do like these kind of stream processing. I think it's a relatively important concept to know. Definitely in case of data engineering, if you're expected to do big data processing, you need to have knowledge on both big data batch processing and stream processing. Even though the technologies overlap, but way of doing things is a bit different. So next up is visuals tools. Like there are some tools which are available for you to use visually instead of like writing down code. Someone who's new to this field, I think, can really hop on. A good example is Alteryx. I've used this one as well. There's Apache NiFi, and then there's GCP Data Prep. You drag and drop like these transformations you're interested in. There's an input drag and drop tool. Then you connect it into a transformation tool. So it's very easy to navigate, at least someone who's new to this field of transformation. I think you can check this Alteryx tool. I think it's paid, but maybe there's like a free version. You can just try it out. All right. This is it in data processing. Moving on, orchestration tech. This is where you lay down the pipeline. To schedule and orchestrate jobs, you would need to create pipelines and workflows. So like, for example, first you do this step, then there's step B, then there's step C, which are in parallel of each other. So one of the best tools to work with is, and that's one of the standard tools people work with, is Airflow. It's a code-based DAG you can create. It's a tool you can install using pip. Python-based code you can write down. So you can create tasks within Airflow, and you can have dependencies on tasks. So execute task 1, then task 2, task 3, and you can do in parallel or in series. You can create basically, at the end of the day, you can create basically like this direct acyclic graph, which lays out the orchestration and dependencies in place. And so this is what is being used. And then within that, you can add in your transformation. Can be done via Python, Spark, SQL, etc. but the orchestration is kind of usually using these tools: Airflow, Luigi, NiFi, and Jenkins. I think no need to cover others. Mainly look into Airflow. Definitely use it. I would suggest you need to have some kind of knowledge on Airflow, how it kind of works, because I think that's like the usual tool of choice in terms of data engineering. There is a lot more which companies prefer, some other like GUI based tools, but I think Airflow is kind of standard. You definitely need to check it out. Moving on, which is backend frameworks. This area kind of overlaps with the software engineer as well. So if you want to serve things for some application to use, you need to create backend frameworks. You need to create backend APIs basically. So if you have a model, if you have some kind of data set, if you have some kind of functionality and you want to expose it for another application to use, you essentially create these kind of backend frameworks, and usually you create these APIs. So there are a few technologies within the Python space, which is Flask, Django, and Fast API. I think Flask is kind of the most popular one. Django is a bit more complex, but I think it has a lot more functionality. I think you can stick with Flask and Fast API. All right, moving on, front-end technologies. But I think the first thing which is very important for you to know is Jupyter notebooks, definitely. So by front-end, I mean like you have all this, you would need some kind of an interface to work at or like present what you have done from time to time. Not every time it's required. Sometimes it's just transformation, but you would need to present it. So that's where like tool like Jupyter Notebook is very like really useful. You can display whatever information, whatever you've done in like in terms of charts, graphs, or just as a simple notebooks and showing what you've done. That's one of the key. Data scientists definitely use a lot more Jupyter notebooks than us, but I think for data engineering, from time to time, you might need a platform to work with Python. I think that's where it's very useful. Other things are like dashboarding frameworks, the paid ones, which are very useful, like Tableau, Google Data Studio, and Power BI. They exist in this business intelligence space. This kind of sometimes overlap, but like in terms of data engineering, you might be required to present what you've done, present data in some format. So I think that's where you would need to know these technology. Not required, but yeah, good to know at least one of it, I guess. Other is like there are Python frameworks which need like pip frameworks that natively supports for you to build front end dashboards, etc., which includes like Streamlit, Dash, Plotly. IPy widgets can be integrated within Jupyter Notebook for you to create this front end. There's also Gradio, which I think has been acquired by Hugging Face, but I think it's also providing like some kind of front end. Apart from that, there's JavaScript frameworks. I will not go into detail, but they also exist in this space. These come more into like the software engineering line and less of data engineering. But yeah, it's good to know that these exist. At least like what kind of technologies exist, like React, D3, C3. These are the graphing libraries, simple charts. Good to know. Maybe it's not required at all. I think you can just skip it. And moving on, this is also like a really important part for data engineering, which is automation, automating the code and deploying the code. So automation and deployment. There's a few things to it. I think let's go from bottom up. First is containerization. I think this is a really important space, and this is like one of the important technologies you need to learn. Dockerization is really important, so you need to work around Docker. So basically what Docker does is kind of help you package your code base dependencies as an image. You can consider it as a disk basically. You can deploy it anywhere in any machine which has Docker installed basically. So yeah, you use Docker to build these images. Docker Compose is basically used to run these images as containers later on. So there's a lot more detail to the concept. Definitely it is a required thing to know containerization, how Docker kind of works. I think next up is infrastructure as a code. I've used a combination of Terraform. I've used a combination of Terraform and Ansible together in mostly. So Terraform is basically used to render out infrastructure, and Ansible is kind of mostly used for me to automate stuff. So automating like this deployment. So on a click of a command, like on just adding a few commands, I can just deploy remotely from a remote host or from a local host to a remote easily, and I can automate all these like deployment steps with shell scripts, etc. So yeah, these are like the important technologies. Shell scripts, Ansible, and Terraform are like important in terms of workflow. Definitely check them out. These are for like a bit advanced stage in terms of data engineering, but I think they also qualify as a required item. So definitely check out infrastructure as code. Next is continuous integration, continuous deployment. There's a few options. Jenkins can be used. GitHub Actions can be used to continuously integrate what happening. So basically, as soon as you commit into master branch, this can automatically deploy your code to the production. I think that's where this continuous integration is. So there's no bottleneck onto a human person. It's just everything is kind of automated. There are two more branch which I'm not going to cover, but yeah, feel free to check it out. There's machine learning. I think these concepts is also really good to know. At least machine learning operations. As a data engineer, you might be required to deploy these machine learning models using some kind of technology such as Google AI platform, Kubeflow, MLflow. So you can just deploy models. I think it's this part is actually, I would not say is optional. This part is kind of required, but you should know like how to deploy. At least one is good enough. Maybe just check out one. Maybe check out SageMaker on how to deploy apps, Google AI platform. I think it's good enough. MLOps is an important stage, but not as important, I would say, but it's good to know. Apart from that, you would need to know like basic fundamentals, what machine learning is, what is a machine learning, what is linear regression, logistic regression. Good to know, not required. And then there's machine learning frameworks to work with, scikit-learn, TensorFlow, PyTorch, Keras. Good to know that these technologies exist. It's not required. If you're interested in the ML side of things, I think that's when you kind of go down this route and check out. And then there's like a separate job profile of machine learning engineers that usually work on a day-to-day basis with these technologies. As a data engineer, you get to touch them from time to time, but you don't use it as often. If you want to experiment, yeah, I've done that in my case, but yeah, not as important for data engineering. The last step is integrated platforms. There are basically integrated platforms for like data scientists, data engineering, like all the workflow kinds of comes together in these integrated platforms together. So examples are AWS SageMaker, Databricks, Google Vertex AI platform. Maybe Hugging Face is also kind of a thing. I'm not sure. Maybe I'll remove it. Yeah, I'll just kick it out for now. So yeah, this is the few options. I think it's good to know that they exist. I think platforms like Databricks need some time for setup. If you have worked with it, I think it's okay. But I think Databricks is also like an important platform for data engineers to work with. For now, it's good to know that what it is. Maybe okay, not if you haven't done hands-on. I think it's kind of okay. So yeah, I think that's about it. So I will leave a link for this mind map and the details in description. So yeah, I hope this video was useful for you. If you gain value out of this, definitely hit the like button and subscribe to my YouTube channel. See you in the next one.